These are your 8-5C notes, fact solving by factoring. We are going to learn today how to solve equations that have something squared. And so it will involve using factoring to help us in that process. And so what we need to do is before we can actually do the factoring, we have to explore what that actually means. So we're going to have a rule that involves zero, the number zero. So just take a few seconds, look at these three problems I have in front of you, and think to yourself, what would make that statement true? And the first quantity, what would you multiply 3 by to make it equal 0? And the answer, I'm hoping, that you got was 0. In order to take any whole number, any positive or negative number, and multiply it by something to get a value, a product of 0, 0 has to be part of that problem. It doesn't matter if it's a positive or a negative number. It doesn't matter if it's the first number listed or the 20th number listed in the multiplication. If 0 is going to be an answer, 0 has to be part of the problem. And in this particular case, it could be both numbers, 0 times 0. So the reason I point that out is the one rule that we're going to use today to determine, to use factoring to solve these things is called the zero product property. The zero product property, I like to refer to it as ZPP. It's just easier to say. If you actually break down those words, it makes sense. It's the rule. Property just means it's a rule. Okay, that's a fancy name for a math rule. So it's the zero product rule, that if you have a product, an answer to a multiplication problem, one of those numbers that you are multiplying has to be 0. So if the product of two factors is 0, if the answer to a multiplication problem is 0, then at least one of the factors must be 0. So I have these three statements here. If 3 times x is equal to 0, then either 3 is equal to 0 or x is equal to 0. I took both of the factors. 3 is a factor and so is x. Those are your factors. It's a product that equals 0. Now, it seems ridiculous to say that 3 is equal to 0. That's not an option. 3 is not equal to 0. 3 is equal to 3. So I don't even need to list that one. It's kind of ridiculous to even go there. But so in that case, x must be equal to 0. That's the value of x. I could have also solved that just by using inverse operations. Divide by 3, divide by 3. X is still equal to 0. Look at the second problem. X times x plus 2 is equal to 0. I have a product. I'm multiplying the number x. I don't know what that number is, but I'm multiplying it by x plus 2. And I don't know what x plus 2 is. It's just some other number. It's whatever x is plus 2. So I want you to understand, first of all, that there's two numbers there, that there's two factors, x and x plus 2. X plus 2, that whole quantity, that whole set of parentheses is one number. It's not x, it's not 2, it's the number 2 more than x. And so there's two factors there. So what I can say is either the first one, x is equal to 0, or the other factor, x plus 2 is equal to 0. And what that does is it creates two mini equations. So this little mini equation is already solved for us. X could equal 0. If x equals 0, what this would equal is 0 times 2, which is 0, because I plug in 0 for those x values. But in addition to that, if x plus 2 is equal to 0, and I solve for the variable by subtracting 2 from both sides, the value of x being negative 2 would also give us 0. And I want to show you that. If I plug negative 2 in for x, I get negative 2 on the outside, and then negative 2 plus 2 in the inside. Negative 2 plus 2 makes 0. You have negative 2 times 0. It does equal 0. So what you're going to find is when you solve using this property, you're going to get two answers. You could get more answers, but a lot of times you're going to get two solutions. And the first one, we only had one solution. In the second idea, we have two solutions. So we put them in a nice little solution set. And we say, well then, if that's the case, then x is equal to 0 or x is equal to -2. If you look at the third option here, I am multiplying. Here's my multiplication symbol. When those parentheses are written back to back, we're multiplying two numbers. My first number I'm multiplying is the quantity x plus 3. And the second number we're multiplying, or second factor, is x minus 4. I'm multiplying two numbers together and it equals 0. So what I can say then is either the first number, x plus 3, is equal to 0, or the second number, x minus 4, is equal to 0. If the first term is the one that was truly equal to 0, then x equals -3. You just solve that little equation. If x minus 4 is the factor that was 0, I'd add 4 to both sides, and the value of x would have to be 4. You're looking for the value that makes that statement true. So if I made x equal -3, I would get the quantity -3 plus 3 times -3 minus 4. I don't even care what -3 minus 4 is because 3 minus 3 is 0. 0 times anything is 0. And if it was 4, if x was equal to 4, I'd have the quantity 4 plus 3 times 4 minus 4. 4 plus 3 is 7, and then the 4 minus 4 is 0. So I'm not saying it's both at the same time, but if you plug in a -3, you get the answer 0. If you plug in +4, you get the answer 0. And so we have two solutions that work. -3 makes that statement true, and so does +4. So that right there is the one rule we use when we factor to solve. Okay, so we haven't quite factored yet. Two parts to using the ZPP rule. The first thing you have to have, you must have a product. You got to have multiplication. It's the zero product property. And the second part is the product must be 0. Hence the name zero product property. It's the rule about having products that are equal to 0. Okay, property just means rule, ZPP. All right, so we factored. Last couple days we've been factoring. Now we're going to use factoring and the ZPP to help us solve equations. So remember, when we solve, we're going to get a number for our answers today. We're not going to get products or binomials or a distributed property, GCF. We are going to get a number. So the very first thing you got to do is you got to get it equal to 0. You got to bring in 0 first. ZPP, 0 has to happen first. So to get 0, we use inverse operations. We add, subtract, multiply, and divide to get things to move to the other side of the equation. After you get it equal to 0, now you probably have a bunch of addition and subtractions, so you need to factor. Okay? Factor to get a product. You're going to want either a GCF times a product or binomial times binomial, and those will equal 0. Okay, so we need to make that one side of the equation turn into a multiplication problem, and that's where factoring comes in. So you either factor out a GCF or you'll factor by grouping. After you factor to get the product, you're going to set each of the factors equal to 0, like I just did on the last page, and then you're going to solve just like I did on the last page. So let's go ahead and try this. 1 and 2 are already factored. ZPP, do I have 0? Yes, I have 0. Do I have a product? Yes, I have a product. So because I already have 0 and I already have a product and it is already factored, I can skip right to those steps 3 and 4. X plus 2 is equal to 0, or x minus 3 is equal to 0. Those are two numbers. This is the first number. This is the second number. There are two factors being multiplied together that equal 0. In order to get 0 when you multiply, one of them has to be 0. If x plus 2 is the one that's 0, I can subtract 2 from it, both sides. X equals -2. If x minus 3 is the factor that equals 0, we don't know what that value is because of the x. But if x is equal to 3, the second quantity becomes 0. So there's actually two solutions that make that statement true. When x is negative 2, that product will equal 0. And when x is equal to 3, that product will equal 0. Let's try number 2 here. The only difference with number 2 is one of our factors is a little bit more complicated. So we have two numbers being multiplied together. So we have a product and we have 0. We have ZPP. My two numbers that are being multiplied together, d minus 5. I don't know what d is, but whatever d is, we're going to subtract 5 from it, and that's our number there. And then the factor 3d plus 4. So we take each factor. Maybe d minus 5 is equal to 0, or maybe 3d plus 4 is the one that's equal to 0. If d minus 5 is the factor that's equal to 0, that means that d, the value of d, is equal to 5. If 3d plus 4 is the factor that's equal to 0, we're going to subtract 4 first. Okay, we want to take care of the stuff away from the variable first. So then we end up with 3d is equal to negative 4. Divide by 3, divide by 3. So you just have to do two steps. d is equal to negative 4/3. So two solutions, we just put them in the fancy solution set because there's more than one solution. So the values of d that would make that statement true are 5 and negative 4/3. Not at the same time. If you plug in 5, the first quantity will turn into 0. When you plug in negative 4/3, the second quantity turns into 0. I only need one of them to turn into 0 to get a product equal to 0. All right, let's step it up. I think these are our last three problems. So looking at number 3, I have 0, but I do not have a product. I have 0, but I don't have multiplication. So this is where we have to factor. So now we have to do, we already had step 1 done because it was equal to 0, but now we have to make it a product. I recognize that there's 2 terms, so that must mean that I can't use grouping because I would need 4 terms to use grouping. So I'm going to take out a GCF. And I realize that the greatest common factor here between these two terms, I can take a 3 out of 3 and 15, and they both have an x. So I'm going to divide both terms by 3x. Put that on the outside. 3x times x minus 5 is equal to 0. Now I have a quantity equal to 0. And so now I can say either, actually I could say 3 numbers are being multiplied together there. I actually have a factor, 3 factors. 3 times x minus 5. So 3 could equal 0, or 3x could equal 0. I'm sorry, x could equal 0. Or x minus 5 could equal 0. Some people like to keep the 3 and the x together. I don't care. We do know, though, if you say 3 equals 0, that that's nonsense. So that one's out. X equals 0 is already solved for us. And then the x minus 5, if I just add 5 to both sides, x is equal to 5. Okay? The only other way that could look is somebody could have said 3x equals 0. Well, you still get 0. You just got to show the work. So I almost like this way better just because it's a little bit easier. So we still got 2 solutions here. My 2 solutions were 0 and 5. You can always check your answers by plugging them in. If I plug in 0 for x, I get 0 squared, which is 0, times 3 is 0, minus 15 times 0, 0 minus 0 is 0. And when I plug in 5, I get 5 squared is 25. 25 times 3 is 75. 15 times 5 is also 75. 75 minus 75 gives you 0. So it works. Number 4, we don't have 0. So the first thing we have to do is bring this over to the other side using inverse operations. To make a number go from one side of the equation to the other side, you have to do the opposite sign. This is a positive 7x, so I'm going to subtract x. And that leaves me with 0 on the right-hand side. X squared minus 7x is left on the left-hand side. So step 1 is done. I got 0. Step 2, I do not have a product. I need to factor. Greatest common factor is x between these two terms. Put that on the outside. X times the quantity, x minus 7 equals 0. I have a product that equals 0, enter in ZPP. So x is equal to 0 or x minus 7 is equal to 0. I have two factors, x and x minus 7. You set both of them equal to 0. This one's done for us, which is fantastic. And then x minus 7, I'm going to add 7 to both sides. So the other solution is x equals 7. So my two solutions here are 0 and 7. Last problem, 4y is equal to 12y squared. We need to get 0. I know I've been moving everything to the left, but I kind of want to leave my y squared out in front, kind of put it in standard form. So I'm just going to mix it up a little bit. I'm going to subtract 4y and just move the 4y over to the right-hand side. It's okay. There's no rule that says you can't have 0 on the left or the right. You just have to have it equal to 0. So now I have 0 is equal to 12y squared minus 4y. And then GCF, take out its greatest common factor, divide by 4y, divide by 4y. And so 0 is equal to 4y times the quantity, 3y minus 1. Remember, when you factor a 4y divided by a 4y, the 4's simplify to 1, the y's simplify to 1, so that becomes a negative 1 there. I have a product that equals 0. I can say 4 is equal to 0, or y is equal to 0, or 3y minus 1 is equal to 0. Technically, I'm multiplying three things together there. 4 times y times 3y minus 1. 4 can never equal 0. Y equals 0 is done for us. And 3y minus 1 equals 0. We're going to add 1 to both sides. 3y equals 1. Divide by 3. Y equals 1/3. So my two solutions are 0 and 1/3. It will not always be 0, but you're going to see a lot of zeros in your answers for this lesson until we get into grouping. And I didn't show you with grouping because I figured you guys could figure that out. So we can talk about that in class. All right, so your lesson summary. What is ZPP and what must you have to use ZPP? Two things. And then solve by factoring. Good luck.